I have a confession to make. Although I've graduated with an astrophysics degree, I have never touched a telescope in my life. But that is soon about to change. I officially started my PhD on the 2nd of October, but about a month or so before that, I got an email from 2 current PhD students asking if I'd like to join them on an astronomical observing trip in Palma. And obviously, I said yes. There are many worse ways to get your first observing experience. Plans for this specific observing trip have been attempted 3 times before, but they all got derailed. Twice was due to a storm, and 1 time was due to a volcanic eruption. So hopefully things go a bit more smoothly this time. I heard it was cold on the mountain, so I prepared for the worst. There are broadly 2 kinds of astronomy. One is observational, where you go out and collect real-world data that you want to do your science with. And the other is simulation-based, where you create a model of some phenomenon that is too tricky or otherwise impossible to observe. For this project, we need some real-world data. So this is observational astronomy. That's why we're even bothering going up this mountain to go and collect it. Otherwise, without the data, there's no science we can actually do. We plan to be observing on 5 dark nights, the nights from the 9th to the 13th of October. So a full working week essentially, Monday to Friday. Today is the 7th of October and I'm in Madrid waiting to go to La Palma tomorrow to get a tour of the telescope. The whole aim of this observation run is to investigate the different effects that galactic bars have on their host spiral galaxies, particularly the effects that they have on star formation rates within the galaxies. We'll be looking at samples of strongly barred, weakly barred, and non-barred galaxies, 7 of each, so 21 galaxies in total, and we'll be measuring their star formation rates along the bar and perpendicular to the bar. To be a bit more sciencey about it, we'll be looking for high levels of O3 emission and H-alpha emission. This is because they act as tracers for star formation. We already have visible images of these galaxies thanks to DESI, so we'll be focusing on getting spectra from these galaxies, so looking at their chemical composition, to get clues about their star formation rates. For that, we'll be using the intermediate dispersion spectrograph on the Isaac Newton telescope. Now I'm at the Isaac Newton telescope. I'm in the building where the telescope is housed. Traveling here was a bit of a pain. All in all, I needed a train to a plane to mainland Spain, and then another plane to La Palma, and then a taxi from La Palma to our residences. Then we walked for an hour in the dark, up a mountain, to the telescope where I am right now. So right now we're about 2.5 kilometers above sea level, and yeah, I'm tired. So every morning after observing, we'll make our way back down to the residences where we need to stay for some much needed rest. Then in the evenings, we'll come back here and start observing. Today we had a quick pre-tour of the observatory, so to speak, by someone who was already here. So just a bit of an introduction to the instruments and software that will be used, health and safety stuff for us and the telescope, etc., etc. And now our main observing run begins on the Monday evening, which is tomorrow evening. Or technically, since it's past midnight now, this evening. All this observing will happen after a proper, more formal tour in the afternoon. Observing seems like it will be interesting, of course, but it will also be quite difficult. You basically have to become immediately nocturnal since all your work happens at night and you sleep during the day. Before I talk about my observing tomorrow though, I think I need to give a bit of scientific context to what will be going on. So I'll briefly explain what bars are, why H-alpha and O3 are traces for star formation, and how bars potentially affect star formation rates within spiral galaxies. Bars are galactic structures going through the center of a galaxy. They're typically found within spiral galaxies, but also lenticulars, but we'll just focus on spirals for now, and they're made of stars. Bars are found within roughly 2/3 of all spiral galaxies, and they affect the motion of stars, dust, and gas within their host galaxy. However, we don't know if all bars behave the same way with regards to affecting star formation, strong versus weak bars for example, and that's the point of these investigations. Having said that, we do think that different bars could affect galaxies in different ways. This is because, for example, if you look at strong bars, they're more common in quiescent galaxies. These are galaxies that have little to no star formation going on, which suggests that they may be effective in quenching. And quenching is when star formation slows down and eventually stops. That is when the galaxy is quenched. This is in contrast to weak bars. Weak bars are found in quiescent galaxies and galaxies that are forming stars. So there's a bit more variation where weak bars are found. H-alpha is emitted by ionized hydrogen. And H-alpha acts as a tracer for star formation because such ionization can only take place when UV radiation from young, energetic, short-lived, massive stars ionize the surrounding hydrogen. So when we see this H-alpha emission, we can be pretty sure that there's star formation going on. O3 is a tracer for star formation with similar reasons as for H-alpha. There's plenty of oxygen in the environment and the UV radiation is ionizing the oxygen, which is releasing O3 as emission. So when we see O3 and H-alpha together, we can say, okay, there's most likely star formation happening around here. Of course, you can't just rock up to a telescope and begin observing. There are many things you need to do beforehand before you get to this stage. These things include calibrating our telescope, filling the cryostat to keep our instruments cool, ensuring various machinery settings are all working, monitoring the weather, etc, etc. A lot of these things actually take part in the afternoon before the evening that you start your observations. But some things like checking the weather are basically happening all night that you're taking your observations. Because if the weather gets too bad, you actually have to close the telescope. I didn't have a part to play in preparing the research proposal or anything like that, so the most important thing for me today was just to pay attention to everything that was going on, because tonight was my first night of taking observations and keeping updated records in our logbook. Updating the logbook just involves noting down what was done with the telescope, so testing, calibration, how long we were observing for, what time we were observing, that kind of thing. Nothing too crazy. And observing, which is the more glamorous thing, at least on paper, involves operating the telescope. So pointing it at the right place, making sure we're collecting spectra over the right part of the galaxy, all the normal stuff. You know, selecting the right target, choosing the exposure time, and manually calibrating things. The galaxy that I took observations of was one of the strongly barred galaxies, and luckily the weather was clear, so observations came out fine. Because there's 3 of us at the telescope, we're not all working at the same time. So the plan for me when I'm not doing any work on a telescope is to do some other projects that I have and maybe take a nap. So it's safe to say no time is really going to waste. But while I do take a nap, here's some more galaxy bar science to keep you occupied. With investigations conducted on galaxies with strong bars, it appears that these bars may funnel gas from the outskirts of galaxies towards the center. This gas may otherwise have been used for star formation. When this gas arrives at the center of the galaxy, however, either a starburst is triggered when there's an exceptionally high star formation rate in the galaxy, we're talking about hundreds of stars a year even, and then all of the gas is depleted, or the gas gets too dynamically hot, preventing star formation. Either way, star formation eventually stops, either because it's run out of gas creating all these new stars very quickly, or because the gas is too hot and it's moving around very fast, just zipping around everywhere, and gravity doesn't have enough strength to collapse it down into a gas cloud where star formation will happen. And because this investigation has only been done with strongly barred galaxies, we want to see if this is true for weakly barred galaxies also, and just see what's happening. I was so tired that I forgot to record this, but this night of observations went well. We measured data from 3 galaxies fully, so along and perpendicular to the bar as intended, and then partly for like 2 or 3 galaxies. I'll have to check the observation log. So we finished now, and once you finish at a telescope, you can't just go home. You still have to do the check-out procedure, kind of like the check-in procedure, but in reverse. So you refill the cryostats, even though you did that in the beginning. You just checking everything's working. But the first night was a success. It's now roughly 8 a.m. and I'm so tired and I'm going to bed, and I'll probably wake up just before observations on the second night of observing. So today's Tuesday, and in about an hour we'll be leaving to the telescope for observing, and the sky is clear blue, no clouds that can be seen, at least from my window, which is good. So here's hoping it stays like this all night. Although one thing I learned recently is that just because there aren't any clouds in the sky doesn't mean your viewing conditions will be optimal. This is because you can have turbulent air in the atmosphere affecting your seeing conditions, and there will be dust. There actually is quite a lot of dust right now in the atmosphere, even last night. This is because of sand coming from the Sahara Desert. So this is impacting things a little bit, but it's definitely not disastrous. Okay, so the plan for today is that I'm going to be the first to operate the telescope after all the setting up procedure and stuff, checking the weather, blah, blah, blah. So hopefully it goes well. I'll probably be on this for 3 or 4 hours, before we then switch over to the next person, and I might take a break, depends how I'm feeling. So it turns out the weather was actually really good at the time we were supposed to observe. No clouds, very little Saharan sand, low humidity, but we soon ran into an issue quite early on. After doing all of our opening telescope steps, we found this weird box with a padlock telling us that the telescope was locked off. And the lady who came to help us actually said she's never seen this before, so we were panicking a tiny bit. So we called for help at one of the nearby telescopes, the William Herschel telescope, but the issue wasn't resolved. Then we ended up having to call the head of operations for the telescope, and the issue was kind of resolved a bit later. The lady who came to help us actually had to cut off the padlock with bolt cutters, and then eventually the issue was resolved. So the rest of the observing night went quite well. One of the things that has to be done before each observing night, ideally in the evening, is taking what are known as biases, arcs, and flats. Each of these essentially have to just do with different kinds of calibration. Taking an arc spectrum, aka taking arcs, is when we take a known emission of a chemical and show it to our spectrometer. We can use this to find which pixels in our spectrometer correspond to which wavelengths of light. This is essentially a calibration spectrum for our spectrometer and will make it much easier for us to tell which chemicals are present in the region of the galaxy that we're looking at. Taking flats is where we point our telescope at a plain, uniform background. This could be a twilight sky, or in our case, the dome of the telescope. This shows us how uneven our sensor is. This is because not all sensors are made perfectly. And all these imperfections in our sensor, now that we have a record of them, can be sorted out in processing. And lastly, bias frames are used to remove noise from our final measurements. We have uniform light shining onto our spectrometer, and it's essentially telling us the response of each of our pixels in our CCD. In an ideal world, each pixel would be uniform, but that can't happen because engineering is imperfect, so we have to account for that fact once we've taken our observations. We then just had to observe some standard stars for flux calibration, and then we began observing. I ended up observing first tonight, and I observed 3 of our targets. I observed weak barred 6, non-barred 6, and strong barred 6. This took about maybe 3.5 to 4 hours, but this was after our delays, so I maybe finished it around 2 or half 2. All observations again, like yesterday, seemed successful. Great weather, all green on the observing panel, no major issues apart from what happened in the beginning of the night, but everything was done. We did finish observing a bit early though, because it got too light for our specific targets.
We have finished observing, but it's still quite dark. The reason we finished is because our targets aren't on this side. They're actually on the bright side. So we have to stop early. If our targets were on the other side of this telescope, we could probably still be doing some observing, but they aren't, so we've got to pack it up for the night. It's still around 7 a.m. though, so we have done a lot of observing today.
I'll be taking flats and arcs first, then I'll be off while the other 2 are observing. This is actually the last day when there'll be 3 of us here, soon there'll be 2 of us, meaning I can't take my nighttime naps anymore, which is not going to be fun.
Again, the weather looks very good. This is day 3 of observing, and I'm about to go. I need to be quick. I think people are waiting for me, but no clouds in the sky. Now hopefully, the forecast doesn't change.
So on day 3 of observing, we arrived at the telescope, switch on the light, and find out the telescope isn't parked in the direction it should have been. This is no doubt due to the engineers, so we turned it around and parked it where it should be facing. I then took the biases, arcs, and flats respectively, which is all I had to do until 1 a.m, which is when I started taking logs. So I had a relatively chilled night, but that was the calm before the storm, because from Thursday evening to Friday morning, I'll be observing pretty much continuously on that day, which is a bit daunting, but I'm sure I'll rise to the challenge. So we've been taking all these measurements, but how do we know that what we're taking is correct, or at least on the right track? One thing that can be done is to do a quick and dirty reduction of our data to see if we're collecting what we're expecting. This was done by one of the other PhD students here. So he tested what we observed, and what we've seen from our observing night seems to point out that we're on the right track. We see some H alpha where we expect it, and we also don't see it where we don't expect it. So everything's pointing in the right direction, and that gives us confidence that we're doing the right thing. So that was pretty much it for day 3. On to day 4. So day 4 of observing, my penultimate day, and I feel like I have to say this, but I'm definitely not showing you the same sky every day. It is clear yet again.
Just completely blue skies, no clouds in sight. I mean, considering a cloud did interrupt our observations yesterday, you never know what will happen later, but even then it was momentary. So, we have reasons to be hopeful.
So the plan for me tonight is to observe the whole night, or at least the vast majority of the night. There are only 2 of us left now, meaning our workloads both increase quite a lot. This does mean though that tomorrow I probably won't be observing so much and I can work on editing this video. But yeah, I'm looking forward to it. This will be a big weight on my shoulders. But you know, pressure is a privilege, as they say. I'm enjoying the opportunity. So let's see how day 4 of observing goes. Okay, so I'm a bit out of breath. We had to walk up the mountain today because me and the other guy observing can't drive. The only person who can drive has left today, and it just dawned on me that we'll be walking back down and coming back up again tomorrow. But I'm not exactly complaining because the view is amazing. Although the altitude and the dust do not make for a good combination when you're trying to catch your breath. So, I found a cozy room at the telescope. Today's observations went quite well. We've just finished for the night. So initial targets were acquired and I was observing for the whole night minus a 2-hour break. The good thing though is that, as you can guess, I'm very tired, meaning that when I get back to my accommodation at maybe 8 AM, I should be able to sleep for hopefully a long time. All things considered, everything went well. We observed 4 galaxies tonight. All of our strong-bar galaxies have been observed, which is the primary aim for this whole observing trip, so it can at least be considered a success as of now. We do want to observe some more galaxies though tomorrow, and tomorrow, since it's the last day, we're just going to try and crank out as many as we can. So now I can go, pack things up, walk down the mountain, and sleep, hopefully, refreshed for the final night of observations tomorrow. Today is the 5th and final day of observations. I finally had a good night's sleep. Slept for 7 hours. So I feel ready to take on the day. And I don't know about you, but the sky looks much bluer than it usually does. Again, very clear. Oh, I do see some tiny clouds over there, but hopefully that won't impact our observations. Even though we finished measuring all of the strong bad galaxies yesterday, we're still going to take one more exposure of the strong bad galaxies today. This is because some sand got in the way of our observations yesterday, meaning our measurement wasn't exactly as good as we liked. However, that will only be one exposure of 15 minutes, and then we'll move on to the weak bad galaxies. The weak bad galaxies are basically the second priority after the strong bad galaxies, and because we're looking at the effects that bars have on the host galaxies, it makes sense to do the bad galaxies first. Having said that, we still have observed 4 of the 7 non-bad galaxies, so we've done quite well. I finished with my last day of observations last night, and today I'm going to make my way back home. So what exactly happened last night? So last night we finished observations with pretty much no issue, and overall in the whole week we observed all the strong bar galaxies, took measurements for all weak bar galaxies and 4 non-bar galaxies. This overall would be considered a success because the primary aim was to measure all the strong bad galaxies, and we did that and quite a bit more. So this should be enough information to find out what we want from these galaxies. We did have a few observations with a low signal to noise ratio because of clouds, but that will just make it harder to be sure of what we've seen rather than make the data useless. One of the things I found out a few days ago is that I could be one of the last people to observe at the INT because in April it's going fully remote and closing down. So this makes the experience even more special, I guess. If you stayed to the end of this video, thank you very much for watching. All links and references are in the description below, and I guess I'll see you soon for another very different video about astrophysics.